will be helpful later on. So we will see a relation between drift velocity and current. So for this, what we will do is let us take a small section of a conducting wire. So basically, if we have a conducting wire like this, we have taken just any small portion of it, and we have taken the zoom of it. So it will look like this. Now current is flowing in this direction as per the given circuit. At any moment of time, let's say we have n number, the number density of electrons is small n, and area of cross section is A. This length is L. So n is small n denotes number density of electrons, which means number density of electron means number of electrons per unit volume. Right. Now we want to calculate that what is the total number of electrons in this given part of the conductor. So for that, let us find out the total number of electrons. So total number of electrons in this cylinder that we have chosen is given by number density into volume of the cylinder. Now given this parameter, volume of the cylinder will be A into L. So this is the total number of electrons which is at any moment of time present inside this conductor, this part of the conductor. Now total amount of charge which is passing through this conductor is NE. So the current, we know that current is given by delta Q by delta T. So now a delta Q, that means we will write down NE by delta T. But what is N? N is, capital N is NALE by delta T. Now we can take L by delta T separately. So NEA L by delta T. So what is L by delta T? It is the average velocity with which all the electrons, are moving towards the positive plate. So if this is the current, then drift velocity direction will be opposite. So instead of L by delta T, we can take drift velocity. So current is equal to NEA drift velocity. This is a very important relation between current and drift velocity. Here again I am repeating, small n is the number density, that is number of electrons per unit volume. E is the electronic charge. A is the area of cross section of this conductor. Vd is the drift velocity of these electrons. So this is the relation, which shows that current is directly proportional to drift velocity. If drift velocity increases, current will increase. If drift velocity decreases, current will decrease. Okay?
Excellent.
Yes.
So